Okay, this is January 2010, Module 4, Question 6. State in words Newton's law of gravitation. So again, we've been asked to do this quite a few times. So Newton's law of gravitation states that the attractive force between two masses is proportional to the product of their masses and inversely proportional to the square of their separation. The attractive force for a mark proportional to the product of the masses for a mark and inversely proportional to the square of their separation for the final mark. 3 marks. Alright. Using Newton's law of gravitation, show that the period t of revolution of a satellite is related to the radius r of the orbit by. Okay, so we've got gmm over r squared equals mr omega squared. The masses cancel, and so we now have equals r cubed times omega squared, but omega equals 2 pi over t. Therefore gm is equal to r cubed times 4 pi squared over t squared. Therefore, give me strength. Therefore t squared is equal to 4 pi squared over gm times r cubed. Okay, so gmm over r squared equal to mr omega squared. The m's cancel and then multiplied up across by the r squared to become r cubed. Gm equals r cubed omega squared, but omega equals 2 pi over t. Therefore gm is equal to r cubed times 2 pi over t all squared. It's 4 pi squared over t squared. Multiply up the t squared, divide across by the gm, and we get 4 pi squared gm equal r cubed. And that's, again, that's what we were looking for, QED. Well, now we come to a calculation. We've got value for the radius of the Earth, the mass of the Earth, and a satellite orbits the Earth in a geostationary satellite. So what is meant by geostationary orbit? Well, geostationary orbit then means that the satellite always remains remaining above the same point on the Earth. Or relative to the Earth. And that's because the period of the satellite equals 24 hours. Right, so calculate the height of the satellite, or calculate the height of the satellite above the Earth's surface. Okay, well, again, just going to go back and we're going to use this t squared equal to 4 pi squared gm over r cubed. So t squared equal to 4 pi squared gm over r cubed. Therefore r cubed is equal to gm over 4 pi squared times t squared. So that's equal to 6.67 times 10 to the minus 11 times the mass of the Earth was 5.98 times 10 to the 24 times, okay, and we're going to have to times 24 times 3,600 to change it into seconds, all squared, divided by 4 pi squared. Put those into your calculator and do the calculation, and that gives us then that the height is 3.59 times 10 to the 7. So 3.59 times 10 to the 7 meters. Calculate the linear velocity of the geostationary satellite. Well, we're going to use t is equal to 2 pi over omega and v equals r omega. Therefore, if we rearrange that, okay, that means that v is equal to r times 2 pi over t. So it's equal to, well, we just worked out the satellite there. The satellite height, so that's 3.59 times 10 to the 7 times 2 times pi divided by 24 times 3,600. Fill those in, and that gives us 3072 meters per second. So 3072 meters per second.